Okay, we're looking today at sketching curves of various degrees. First thing to consider is where they roughly start, roughly end. Now, it depends on whether we've got the highest power of x is even or odd. If the highest power of x is even, positive ones will start up here and finish up there. So for example, x squared would look like that. X to the fourth would start up there and be a W shape potentially, like that, and so on. X to the power 6. Negative x squared will be an n-shaped one, and any negative x to an even power might be like an m shape where x to the 4, for example, would start down here and finish down there. If it's odd, it'll start in opposite quadrants, and finish in opposite quadrants. So if it's positive, like a straight line, would start down there and finish up here. X cubed starts like that and goes that way. And if it's a negative x cubed, negative x to the 5, it would start in the upper one and finish in the lower one down there. Okay. Looking at three different types of errors. If your turning point is too pointy, it's supposed to be a curve, don't forget, like that. So if you've got a pointy turning point, that's not good. If you're makes me laugh, this one. If the curve goes backwards here, so for example I've got an x cubed and it goes like that, and that's quite an extreme one, but I do see ones where it tends towards going almost straight up and veers slightly to one side. And the last one is the most important one, because often you're asked to sketch and solve simultaneously, say how many solutions you've got and so on. So I've got, for example, a quadratic and a cubic here. Cubic's too shallow. As x gets large, x cubed is massive compared to x squared. So there is no way in the world that my x cubed curve is going to sort of gently go off like this, whereas my x squared one goes there. And this is a really common one. These two curves will intersect somewhere over here. This one will get steeper as that one is actually shallower in comparison, so it will cross over somewhere over here. So you've got to make sure that the higher powers of x get steeper at the ends than your lower powers of x. So that's a real biggie. So let's have a look at a few examples then. We're given an equation y equals 5 bracket x plus 2 bracket x minus 1 bracket x minus 4. We're asked to sketch it and expand it. So the sketching part is moderately straightforward. Remember, when you're asked to sketch curves, if you just put the picture on, that's artwork, it's maths, we need numbers. So in particular, this one, for example, I can solve each of the brackets equal to 0, and it's telling me where the curve is crossing the x-axis. So the y-axis, there's the x-axis. So it's crossing at -2, 1, and 4. So I can put a thing at -2, it's crossing there, 1, and 4 is the sketch. I can also solve where it's going to cross the y-axis by sticking x's 0 in. And I can do 5 times 2, 10, times -1, -10, and then times -4 is +40. So I'm going to do my sketch like this. It's going to cross somewhere up there at 40. Now, the other thing that I see quite commonly when I see cubics in particular is that people, for some reason, want the turning point always to be on the y-axis. It might be on the y-axis occasionally. It might be close to it. And in this case, it's going to be moderately close to it. I would say it's roughly going to be halfway between -2 and 1. It's not symmetrical like the x squared would be. It's not necessarily bang in the middle, but I can't assume it's going to be on the y-axis, so I'm actually going to try and make it obviously not on the y-axis. So I know it's going to start down here because it's x cubed, go through there, go up, and begin to go down, through the -1, through the 4, and then there like that. And that hopefully is not too shallow, not too steep, and it doesn't curve back on itself, and it crosses there at 40. That's my sketch of the curve. Next thing we're going to do is times it all out. I'm going to do the x minus 1 times x minus 4 first to get x squared minus 5x plus 4, and times that by 5x plus 10. And that's what I'm going to times out. And the best way to multiply out when I've got lots of terms, I'm going to do them in columns. So I'm going to do 5x times x squared, 5x cubed, 5x times the minus 5x minus 25x squared, and 5x times the 4 plus 20x. Then times everything by 10, plus 10 x squared minus 50x, and then plus 40. And I was expecting that at the end, so y will equal the 5x cubed at the start, minus 25 plus 10, minus 15x squared, plus 20 minus 50, minus 30x plus 40. I was expecting that plus 40 because that's my constant. That's where it's crossing the y-axis. Okay, so that's that. Same deal for this equation over here. Y equals bracket 3 minus x times x minus 1 all squared. So I've got a cubic again, but because it's minus x times x squared, it's going to start up here, finish down there. Okay, so it's going to be negative. It's going to go like this and this. But I've only got two brackets. What's going to happen in this case is going to cross the axis as x is equal to 3. When I solve 3 minus x is 0, I get x is equal to 3. But the x minus 1, what it's going to do at x is 1, is going to touch there, either that way around or this way around, because it's got a repeated solution because of the squared. I know that it's actually going to touch going this way around because of the shape of it. It's going to start up there, touch there, and go like that. But let's have a find out and see where it's going to cross the y-axis. Stick x is 0 in, I get 3 times minus 1 squared, which is 3. So here's my shape then. It's going to do this. Do a little thing like that, and then like that. And I'm going to see that it crosses at 3 there. So it's touching at 1, going through 3, and crossing the y-axis at 3. And expanding it, I'm going to say y equals 3 minus x, bracket, x squared minus 2x plus 1. So times by 3, 3x squared minus 6x plus 3, and times by minus x cubed plus 2x squared and minus x. Lump all together, y equals minus x cubed plus 3 plus 2 is plus 5 of them. Minus 6 minus 1 is minus 7 of them, and then that plus 3, which is my constant, where it's crossing the y-axis there. That's that. 3 more examples to look at. Another one just says sketch. I've got a square bracket and 2 more brackets, so this is a 4th power x, the power 4. So I'm expecting, in this case, because it's positive x, I'm expecting a W type shape. In this case though, it's going to touch at minus 1, there. It's going to cross at 2 and cross at 3. And the shape of it's going to go like this, touch there, go through the y-axis at positive, and just do a little rinky-dink like that through the 2 and the 3. So I'm expecting the y value here when x is 0 to be a positive value, and it is. It's 1 times minus 2 times minus 3, which is 6. Yet again, it's going to turn somewhere between the minus 1 and 2, make it obviously not on the y-axis, make it closer to the 2 than the minus 1. So do that. So I'm going to start up here, do a touch there, do a turning point in between, do a little through the 2, through the 3, and like that. Okay, and put on 6 there. That's my sketch. So it's a tad shallow there, but because I'm not sketching with anything else, if I was going to put another sketch on of an x cubed or an x squared, I would make sure that this part went quite steep without curving back on itself. Okay. Example 4 says to sketch 2 things on the same sketch and looking for a number of solutions. So I'm going to be careful here, as I say, with making sure that this one in particular is not too shallow. Y equals 6 over x squared is the easy one, because it's positive x squared. It's going to be in the upper sketches like that. It's a sketch, so it's there and there. When we look at 6 over x, it'll be slightly different values, but the rough sketch looks the same. This is a cubic, positive x cubed, so it's starting down here, finishing up there. It's going to be touching at minus 1 and going through at 2. So minus 1 and 2. So I'm expecting it to touch there, cross in the negative, bottom out somewhere between the y-axis and the 2, and then go through there. As a confirmation, it's going to cross over 1 times minus 2, and minus 2 on the y-axis. There's the shape. Make it obviously turning there, and then there like that. Number of solutions, it crosses the 6 over x squared in one place, just over 2, so one solution. Last one, sketch a reciprocal and a line, find where they intersect, use the sketch to solve an inequality. So 10 over x, 2 quadrants, opposites, because it's odd powers, here and there. Y equals 2x plus 1, we'll cross it plus 1, and have a gradient of 2. It's a sketch, so all I need to do is that, and necessarily I can solve 2x plus 1 equals 0, and say that that is a minus a half for my complete sketch. And then solving simultaneously, so I can say y equals this, y equals that, so I'm solving 2x plus 1 equals 10 over x, times everything by x, 2x squared plus x minus 10 equals nothing. I'm hoping it factorises 2x and 5, x and 4 equals nothing. To get plus x, I need the plus 5x and the minus 4x there. Sorry, next one 4. What am I doing? 2 even. There we go. So I've got that times that. So x equals minus 2.5 or 2. And then if I want the coordinates, I can stick those in to get the y. So I can say when x is 2, y is 5. And when x is minus 2.5, y is minus 4. So it depends on what the questioner wants. If it wants coordinates, go back and check it. Because I'm a bit short of space, I'm not going to write it in there. But for part C, it wants where the line is above the curve. And let's have a look where the line is above the curve. Well, here. So where this crosses at the x is 2, the line there is above the curve anywhere from x is bigger than or equal to 2. But also this point here. So there, from where it crosses at the minus 2.5 up to but not including 0. Don't forget that's an asymptote. So this is a finite range where x lies between minus 2.5 and up to but not including 0. So every value on the line there is above the curve. So that's how we use our sketches to show exactly whether things are going to cross over.